Hey guys, I'm MikroTik Mark with Remote Winbox, and today we're going to be talking about our OSPF network building. And if you missed it, part one, we talked about the planning phase of building a MikroTik OSPF lab network. And today we're going to be talking about the execution of putting that configuration into practice. We're going to go jump into the lab and get all these routers configured with the details that we've presented. So the reason we wanted to make these videos is because we're building a new feature called OSPF Network Mapper. The Network Mapper feature is going to scan your network for OSPF routers, and then based on what it finds, build an OSPF real-time map that shows what the current pathing is to get traffic out to the internet. And that should allow you to validate that your network config matches what you expect to have your traffic path to look like. So one of the things we did not finish at the last step on documentation was actual physical port assignments. And I had been doing some testing with some VLANs. I think today we're going to reassign these as physical ports. So let's go ahead and jump into the documentation here and assign ports. So what we'll do is go ahead and we'll jump in here, put a little text here. We're going to say Ether 1, Ether 2, Ether 3. And so Ether 1 here is going to face internet. And now we're going to have Ether 2 here facing our first downstream router. And we'll just keep it making our port assignments down the way here. And I will make Ether 1 face each of our upstream connections. One of the things I like to do is create a schema or a standard. And what we're going to do here is that we're going to number our routers based on the router ID of the loopback. So in this case, router 1 is 100.127.0.1. And that last octet of .1 is what we're going to use for router ID or router assignment, router name. So router 1 is .1, router 2 is .2, router 3 is .3, router 4 is .4, 5.5, and 6.6. So again, that's just the last octet, and that's just a naming scheme that I like to go with. In addition, I like to say that I'm going to have Ether 1 always the closest internet-facing Ethernet port. So on my router 1, Ether 1 faces the internet. On router 2, Ether 1 faces the first link to the next hop router. Same thing, router 1 or Ether 1 here on router 3 faces upstream. Ether 1 faces upstream, Ether 1 faces upstream. So you can follow whatever schema you like to, but I highly suggest putting some kind of scheme together so that your documentation looks good and your network is easy to operate over time. All right, so now that we've made port assignments, let's go ahead and get this network configured. I'm going to start off with router 1 here, which is connected to, I have a PoE switch that is powering router 1, and I'll just jump in there and get started. Starting with router 1, I'm going to just go ahead and set his host name right off the bat so I can tell which one I'm working on. And we do that by going system identity, set name, and we're going to call this guy router 1. You'll see the prompt there changes to admin at router 1. And now I can go ahead and start configuring here. So I'm going to put a loopback here. And the way that we do a loopback on MikroTik is by going interface bridge add. You just give it a name. Loopback 0. And now I can put an IP interface on that loopback bridge. This is because it's a bridge interface, it'll always be up, and that behaves the same way as what you might see in other vendors' loopback behaviors. So we're just going to do IP address add. Address equals our 100.127.0.1 loopback address. Interface is Ether 1. So real quick, maybe I'll talk through the steps of creating an OSPF network. You don't have to officially put a loopback interface on your device, but it makes sense to because if you have multiple links, if the link that is currently assigned the IP address of this router flaps or goes down, you're going to have a lot of convergence and churn on the network, whereas if it's a loopback interface, which is always up, that network will already be known topology-wise based on its loopback ID. So that means that even if you have a link go down, your router won't go down as far as the topology of the rest of the network is concerned. So it'll result in a lot less churn and a lot less processing overhead on all the rest of the network, including this router. So step one, we're going to build a loopback interface. Step two, we need to have IP addresses on all of our links. Step three is that we're going to configure our OSPF instance. We're going to add networks to that OSPF instance and then configure our interfaces that are able to talk OSPF to neighbors. At that point, we'll have a running OSPF network. And so let's get started. So next up is to add addresses to all of our interfaces. So IP address add, address equals, and I got to look here. We assign 100.126.0.1 and 2. I like to use a /29. I think I mentioned this in the last video because that allows you to have, two IPs on the routers. You could have two IPs in the middle for transport gear, whether that's a switch or a radio, and then another IP available for a PC that might be used to troubleshoot. So when you're having trouble building this OSPF adjacency between these routers, you've got a couple IPs to play with to put on devices to do some IP connectivity testing and take a look at your bridging tables, MAC tables, and understand whether traffic is flowing across the links the way that you expect them to. IP address add, address 100.126.0.9. So because this is my lab, you'll see that there is just no configuration at all. And I've factory defaulted all of these routers with no configuration on them. So they're brand new raw routers that don't have any configuration. So one of the things I like to do when I am working on a network is to check what the current configuration is. So if we do routing OSPF instance print, we can see what the current configuration looks like. You'll just see that it's totally defaulted. And the big deal here is we need to update the router ID. And the way that we do that is routing OSPF instance, and we're going to set the router ID equal to our 100.127.0.1 loopback address. So next up, we need to identify which interfaces we're going to run OSPF on. And these will be the interfaces that we're going to attempt to form neighbor adjacencies on. So the way we're going to do that is to say routing OSPF interface, and we're going to add some interfaces here. So we're going to say interface equals ether 2 and ether 3 are our interfaces facing other routers that are going to talk OSPF. So one of the things that I see commonly is that BFD is not used. Let's talk about just for a moment why I like BFD. So so far we've added ether 1 with used BFD and ether 2 and ether 3 with used BFD equals yes. Now I'm not going to adjust any of the timers, not of the hello interval, dead interval, etc. And that's going to be because the default values are pretty lightweight on the router's resources. But BFD, on the other hand, it's a little bit heavyweight, but it's a protocol specifically built to do some data plane testing. And so what's going to happen is if I use BFD, I'm going to start sending really fast hellos. And those hellos by default will come in at 250 milliseconds and say, hey, I can drop 3 or 4 before I trigger convergence, which means about 1 second of downtime is noticed before I kick in a convergence event, which means I need to set this link to be down, this neighbor to be down, and say that's not usable until BFD recovers. So if you're doing an OSPF network and not using BFD, you're at the mercy of your timers. And again, the defaults there are 10 and 30. So you're going to wait 10 seconds between sending hellos. And then after 3 or 4 hellos, you're going to tear that connection down, which means you might have a outage for 40 seconds before the network is fully converged. With BFD, that's going to be 1 to 2 seconds. So I highly recommend using BFD whenever your gear is compatible. And our last step here is to add our network statements. So OSPF knows now which interfaces to talk on. One of the steps we need to do is tell it which networks to advertise and form adjacencies on. So we're going to go routing OSPF network, and we need to add our loopback interface. So we're going to say 100, network is 100.127.0.1. And area is backbone. We're going to do an add of the network 100.126.0.0/29 goes in the backbone, and 0.8. Now, one thing that I do see commonly is that some folks will go ahead and put 0.0.0.0/0. And what that does is say, hey, every network on the whole planet can be reached through me. I'm a router that can get to everything. That can be dangerous because you can get some pathing issues where traffic flows the direction that you don't want it to go. And obviously that's undesirable. So best practice here is always to make sure that you are putting only network statements for networks that this router is responsible for. So I can see that one of the things I missed was putting my loopback on the routing OSPF interface. So let's go ahead and routing OSPF interface. And our loopback is never going to be able to form an adjacency. So we're going to use a flag here called passive. That means we have a interface here that's not going to form an adjacency. So don't even try. So routing OSPF interface, add loopback 0, passive, yes. And there we go. This router is now configured and ready to talk OSPF to his neighbors. So let's get started on the neighbors. So I'll do an IP neighbor print and take a look here. I want to configure this guy that's on Ether 2. So he's my router 2. And let's go tool, telnet to that guy. Again, these are totally defaulted routers. They have no configuration on them. So I'm just going to jump in here with admin no password because these are completely unconfigured. Always add a password to all of your MikroTik routers and update with at least a basic firewall. I think we'll do some videos later on security. All right, so same steps, system identity, set our name to R2 for this guy, add a loopback, so interface bridge, add name, loopback 0, put some IP addresses on this guy. Move this out of the way to see Ether 2 is going to be .17. So now we have 3 steps left. We're going to update the routing OSPF instance, the routing OSPF interfaces, and the routing OSPF networks. Looks like I forgot to add Ether 1 here because on the last one I didn't have to do Ether 1, but on this one, Ether 1 faces a OSPF router. So let's get an IP address on there. Once again, we're going to add our network statements for all of our interfaces, the passive interface of the loopback, and the 3 links that are facing our other OSPF routers. All right, and at this point, a couple of tests we can do because now we have 2 OSPF routers that are configured. They're facing each other. They should be able to form an adjacency, and we should be able to ping across our link. So we'll start with ping, and we should be able to hit 100.126. .0.1, which is the remote side. Great, we got the packet through. And if we go routing OSPF, neighbor, print, the things we're looking for here, state equals full. So this guy is now able to form an adjacency with a neighboring router. And if we go IP route print, we should start seeing OSPF routes. They're the ones with the O are starting to be learned across the network here. So as we continue to move down the network, we'll add more and more OSPF routes to our routing table. So I'm going to IP neighbor print again, find router connected to Ether 2 here. Admin no password. And away we go again. Systems, identity, set name, R3. Interface, bridge, add name, back 0. IP address, add address 100.127. .0.3 for router 3. Interface, back 0. We gotta add IP addresses for all our links. IP address, add 100.126. 0.18. Ether 1. Update the OSPF instance router ID. Add the interfaces. And one of the things that you may want to do, depending on what your switching infrastructure looks like, / what devices exist between your routers, you'll notice that each of these routers just has one device connected to it. So I'm going to show something that's a best practice here. I'm going to go routing OSPF interface print. And here, Ether 2 is facing router 4. I'm going to make that and the rest of these, I'm going to follow best practice here and change those to be point-to-point links. So point-to-point will mean that there can only ever be 2 OSPF routers on a link that can form an adjacency with each other, and that will save resources, optimize the behavior of the routing protocol. So I'm going to set that as a best practice. You should always do that when may only be 2 routers able to form an adjacency on a link. So the way I do that is by going set network type and point-to-point. Now we just need to add our networks. Running OSPF network, add network 100.127. And the same thing we'll do here is test our connection. We should be able to hit our previous router that's been configured. So 17, perfect. And routing OSPF neighbors. Perfect, we have a full neighbor adjacency with our upstream router. This will get more exciting as we add more routers, and we'll start seeing a lot more in the routing table as well as in the neighbor relationships. All right, so let's find the MAC address of R4. Do IP neighbor print. We know he's connected to Ether 2. And off. Update our router ID. Add our interfaces. Again, we're going to do network type point-to-point on all these new interfaces. The old ones, we already configured R2 without point-to-point, so we're going to just do point-to-point on the other interfaces. And we'll just drop the point-to-point for ether 1. Alternatively, I could go back into ether 1 and router 2, which is connected to router 4's ether 1. And I could say that he does use network type point-to-point, and then when they match, they'll form an adjacency. That's one thing you should know, is that if your two sides don't match with configurations, and that could be with IP addressing, subnetting, the network type, any other BFD, the neighbor relationship will probably not form, and you're going to see unstable behavior or the behavior that won't connect at all in talk routing protocol. Last step is to add our routing OSPF networks. All right, so at this point, we should have some neighbor relationships, and we should be able to ping our neighbors here. So let's go ahead and try that. And you can see here, I tried to ping 100.126.0.49. We've got no route to host. We also tried to ping 100.126.0.25. And again, that's router 3 and router 2 that I've already configured. So those guys should be pingable, and they're not. So let's do an IP address print. And yeah, so it looks like I missed my subnet mask here on these configurations. So let's go ahead and fix that now. IP address, set address 100.126.0.50. We're using the same IP, but you can see that's a /32. It just stuck a loopback IP on there. I need to have these guys be /29s if they want to get off network and onto other routers. So now let's see if we formed any neighbor relationships here. Routing OSPF neighbor print. And hey, look at that. Awesome. We are neighbors with router 2, which is the 0.2 full, and router 3 in state full. We haven't yet configured routers 4 and 5, so that makes sense. So let's go ahead and do that. IP neighbor print. Our next guy, ether 3, is connected here. Let's go ahead and connect to him and get him configured. All right, we're connected to router 5. Let's update his name. System identity. Bridge. Add our loopback. Add our IP addresses. Update our OSPF instance. Add our interfaces to OSPF. Because I already know, I remember we set up router 1 already and did not make it point-to-point. Let's go ahead and set that to be not point-to-point. And finally, let's set our networks. Now we can check for our neighbor relationships. And we can see that we've got an adjacency to router 1 and router 4. Just one more router left to do. So let's do IP neighbor print to get our MAC address and tool MAC telnet to our last MikroTik that is not configured. All right, one more time. All right, we're all configured. So let's check our neighbors, routing OSPF neighbor print. And awesome, we are neighbors with routers 5 and 4. Now, if we do an IP route print, we've got a fair amount of OSPF routes. Matter of fact, on this router, they're almost all OSPF learned routes. And we can just check real quickly to say, hey, how about our 100, 127 networks? We can see here, we know how to get to router 1, router 2, router 3, router 4, router 5, and we are router 6. So we've successfully built our OSPF network. So one of the things I do want to show is how things look from router 4, who is our most network connected router on the network. Let's go ahead and jump into him. It's routing OSPF neighbor print, and we can see we've got a whole bunch of adjacencies here, and same thing. We can see there's a bunch of routes here. We even have some equal cost multipath routes to a couple of these networks because we haven't adjusted any of our distances. So one of the things we'll talk about on the next video is some OSPF network tuning, as well as some troubleshooting. That's all we have for today. Hopefully you'll check out our OSPF network mapper when we release it over the next probably month. And thanks for joining me today, and have a wonderful day. Bye.